Alright, what we're working with today is specifically probability models. We're going to talk about two types of probability models, which are called Bernoulli Trials. And so there are two different types. One thing that has to happen is that they have to be random. And the two different types you have are geometric and binomial. When we do these, there are three conditions that you must check each time. And you can't just put a check mark. You need to write a sentence about it, especially for the AP and my test, because I'm going to assume that you know what it is and you have to write the sentence about it. And so the three things are, they have to have two possible outcomes. There's either a success, which is represented by P, or a failure, which is represented by Q. And so only two things can happen. Even if I have a bag of 5 different color marbles, I can only focus on getting one color, red, versus all the failures, which are not red. I don't look at each probability separately. It's either success or failure for that thing you're trying to look at. The next one is the success has to be constant. And so a good example of when something is not constant is when we're playing cards and we don't put a card back. And so the card deck gets smaller that's dealing, and so our success rate is not constant. The third one is that one event has to be independent of the other event. And there is one rule that kind of makes independence not matter, and that is the 10% rule. And for the 10% rule is if you look at less than 10% of population, that's an ugly F. If you look at less than 10% of the population of everything that you're talking about, then it doesn't need to be independent. So we're going to be doing a problem later talking about M&Ms. And even if I'm talking about a bag of M&Ms, because it's less than 10% of the population, I can follow this rule. I don't have to think that I'm subtracting M&Ms out of the bag. Okay? It doesn't need to be independent. Okay, so again, you have to check those conditions and write it out in sentence, not just write check marks. All right, so the first one we have is geometric. Geometric is when you're finding out how much it takes to get your first success. Binomial is when you count the number of successes. And so that's the main difference between these. Geometric is you're finding the likelihood until you get your first success, and geometric or binomial, you're counting the number of successes. So again, probability is success. So if this is 25, then my failures has to be 75. This formula looks kind of tricky, but let's say I'm having my first success on the third try. So third equals first success, right? And so I'm going to have 2 failures. And so that's why it's x minus 1, because x was equal to 3 here, because I wanted it on my third time. And then my success is 25. And we actually did that last week, or last time when we were practicing this. We would have 2 failures with the blanks, and then we'd have a success. And so geometric probability kind of shows us other ways to do that, and we'll also learn how to use some of it in the calculator. Expected value is the mean. You will use this sum. This one, the standard deviation, not used much. Okay, it's rare that we'll do the standard deviation of geometric models. All right, same thing for binomial models. Probability of success is just still P. Failures is still Q. And N represents the number of trials. When we get down to this formula, some of you are comfortable with combinations and permutations, some of you aren't, and so you'll be able to use this rule, or you will be able to use the calculator method. And again, this is just, I have 5 options, and I'm choosing it to happen 3 times. And so then I'd have success 3 times and failures 2 times. And so that's what it says right here. So if I had 5 choices, I want it to happen 3 times, then this is 3 successes and 5 minus 3, so 2 failures. Okay, so you can use this combination, or you can also use the next method, which I'll show you in your calculator in a second. You will use mean for expected value, and you will use the standard deviation. Okay? One thing we need to put here probably is x is the number of successes. Again, geometric counts when you'll have your first success. Binomial counts the number of successes. Okay, so these are the two calculator things. And so we're going to write it down, and then we're going to look at the calculator. Fourth roll is a 5. So if I did that by hand, if I did that one by hand, I'll do it right here. Fourth roll is a 5, so that means I have 3 rolls that are not a 5, so that's 5 out of 6, and then 1 roll that is a 5. So P, when we do geometric, P stands for perfect. It happens exactly then. And so on your calculator, let's move this over. So to get to the function here, it's under the distribution menu. So get my pen back. Distribution menu. Okay. And so where's my wallet? There's my calculator. So I'm going to hit second, distribution, and near the bottom, it's right down here. I want geometric PDF, and I'm going to hit enter. Oh, this calculator hasn't been updated. So some of you will have a menu. I don't have the menu, and so it's P, which, remember, P is our probability, and so that's 1/6 chance of getting a success. And so if you have it where it says P, you put 1/6, and then X is when it happens, and it's going to happen on the 4th roll. And I hit enter, and so that is my percent. And so 0.096% of the time, my 4th roll will be a 5. Now when we get here, C stands for cumulative. And so that's everything up to there. So this example would be, you get a 5 in 4 or less rolls. So I can get a 5 in a 1, I can get it in a 2, I can get it in a 3, or I can get it in a 4. And so I could happen in any of those times, and so that's why it's cumulative. And so let's change color so we can see the percent. Probably should have drawn the line. There we go. And so again, it's 1/6 and 4. And so let's see what percent that is here. So again, I go back to my distribution. I go up to cumulative because it can happen into up to 4 times. So 1/6 and then 4. And so 51.8% of the time, I will get a 5 in less than 4 rolls, 4 or less than rolls. Okay, so let's look at binomial. Again, binomial is going to count the number of successes. So the first example would be getting exactly 2 5s in 4 rolls. Okay, P stands for perfect. And so my N is the number of rolls I have. So I have 4 rolls. My P is my probability of success, which is 1/6. And then my X is how many I want, how many successes I want, and I want 2. So I'm going to go back to my distribution menu. So I'm going to go second, distribution. This time I'm going to go to binomial PDF, and I hit enter. And so I want a 4. I have 4 trials. Probability is 1/6, and then I want 2 successes. And so for this one, I get 0.116. So that'll happen 0.116% of the time. Same idea for this one, is cumulative. And so getting up to 2 5s and 4 rolls. So this one was saying getting exactly, this is saying getting up to, and so it's still my 4, 1/6, and 2, but now it's cumulative. So I go to my cumulative distribution, and it is 4 rolls, probability is 1/6, and then there's 2 successes, up to 2 successes. And so this one, 98.4% of the time. So you'll get used to using the calculator. You could do it by hand, but by doing it by hand, it gets a little harder. And so now there's some problems that have at least. At least is still what you don't want. And at most is you're going to do the cumulative to the number it says. And once we do some problems, you'll understand what I mean by that. Okay, so we're just going to look at rolling dice. Rolling dice is a Bernoulli trial because you have the same rate of success every time because dice never change. Picking a card, if I put the card back, then it works because then I'm always dividing by 52 and my probability stays the same. But if I'm not putting the card back and I'm holding it in my hand for my hand of cards that I get, Bernoulli trials won't work. Okay, M&Ms, if you think about the entire population and it's limitless, maybe I'm at the factory picking up M&Ms, then the Bernoulli trial works. But a small bag also works because you have to think that that small bag is less than 10% of the population, as long as you're using the percents from the population. If you use the percents from the bag, that would be different. But if you're using the percents from the population, then even if you have a small bag, Bernoulli trials will still work. Egg roulette will not work because it's changing, because what you get for a raw egg versus a hard-boiled egg varies based on what you got before because it's not replacement. Okay, and then political polls, it would depend on if you look at one political poll and you're basing it off the population during that time. It's better to do that versus looking at all the different polls at once. You will see mainly the first 4. You won't see many about the second one, the 5th one. Okay, so we have speckled M&Ms. They're called groovy, and 30% are supposed to be speckled M&Ms. So we need to see if it is a Bernoulli trial. So we look at our list. The first one is that there's success or failure. Yes, so your success is going to be 30. And so that means your failure is 70. You either get a speckled or you don't. And then the next one, what was the next thing we had to check? Is it constant? Yes, even though we have a small bag, 30% is the whole population, so it is constant. And then the last one, is it independent? Well, we're looking at less than 10% of the population. So we should be good. And we also, I forgot to say that yes, success is constant. So you can write it in complete sentences or you can make a little bulleted list. So we need to do these, and we need to first find out if they're geometric or binomial. And it says, what is the probability that the first speckled is the 4th we see? That's saying when you get your first success, so this is geometric. And because I want it perfect, it's geometric PDF. And so my first number again is P, which is 0.30. And then my next number is 4, because that's when it's going to happen. So let's look at our calculator. So second distribution, geometric PDF, 0.30 and 4. And so 0.1029% of the time that will happen. Okay, so the next one says, what is the probability that the speckled candy is one of the first 4? So It's still talking about the first time it appears, but this time it's saying one of the first four. So this is geometric and it's cumulative. It's still 0.30 and 4, but this time, because it's cumulative, I'm going to do the C. So second distribution, go find my cumulative, 0.3 and 4. So this time, about 76% of the time, I'm going to get a speckled one in the first four. Okay. Now let's look at this. How many do we have to check on average to find a speckled? So average is the mean. And so let's go back and look at what our mean says. And for geometric, our mean is 1 over p. So 1 over p, so it's 1 over 0.30. And so I'm just going to divide that. I'm going to do 1, divided by 0.3. And so I can expect to find an average of 3.33 when you check. That's when you'll find your first one. And again, because it's your first, that's why we do the geometric. Okay, so part E says, what is the probability that you'll find 2 out of 5? So because I'm looking for the number of successes, this is binomial. And I'm looking for exactly 2, so it's perfect. And so I'm going to do my second distribution and my binomial. And I believe that your calculators are probably asking you questions. This one just hasn't been updated. And so I have 5 candies that I'm choosing from. My probability is 0.3, and I'm looking for 2 successes. And so 5.3 and 2 successes. And so that's going to happen 0.309% of the time. Okay? Let's see if there's any more examples. So those are all the examples today. We will do more of these, and you'll have some packets with more examples and more videos to help you. The big thing to remember is whether it's geometric or binomial, and then whether it's perfect or cumulative.